Welcome to an overview of decision trees and regression, two powerful concepts in machine learning. Let's start with the basics of decision trees. Decision trees are hierarchical structures designed for decision-making. They consist of nodes, branches, and leaves, forming an intuitive representation of how decisions unfold. Their versatility makes them useful in both classification tasks, like distinguishing categories, and regression tasks, where we predict continuous values. A key challenge is overfitting, but we can manage this through pruning. One challenge with decision trees is overfitting, when the model captures noise instead of meaningful patterns. Pruning helps prevent this by removing unnecessary branches. Pre-pruning stops the tree from growing too complex, while post-pruning trims back an already grown tree. Both approaches balance complexity with accuracy. Now let's look at how decision trees handle regression problems. Regression trees extend decision trees to predict continuous values. Each node partitions data based on feature thresholds, and leaf nodes represent predicted values. Model trees go further by embedding linear regression equations in the leaves, allowing them to capture more complex relationships between features and outcomes. Understanding the strengths and weaknesses helps us choose the right modeling technique. Regression trees combine the strengths of decision trees with the ability to model numeric data. They automatically select features, handle large datasets, and often fit data better than linear regression. Importantly, they don't require advanced statistical knowledge to interpret. Despite their strengths, regression trees have limitations. They require large amounts of training data, and it can be difficult to determine the overall effect of individual features. Large trees may also become harder to interpret compared to simpler regression models. Visualizing the tree structure is crucial for understanding its logic. Visualization makes decision trees easier to understand. Each node represents a feature-based decision, and branches show possible outcomes. By mapping the structure visually, we can better interpret and communicate the logic behind the model. Finally, let's explore how we measure and improve the performance of our models. To evaluate regression accuracy, we often use mean absolute error, or MAE. It measures the average absolute difference between predicted and actual values. Lower MAE indicates better predictive accuracy, and its simplicity makes it widely used in regression tasks. Improving performance involves several strategies: feature engineering to select relevant inputs, hyperparameter tuning to optimize settings, cross-validation to test generalization, ensemble methods to combine multiple models, and regularization to control complexity. Together, these techniques enhance predictive power. In summary, decision trees provide intuitive, rule-based models for classification and regression. Pruning prevents overfitting. Regression trees predict continuous values, and model trees add complexity with linear regression. Visualization aids interpretation. MAE measures accuracy, and performance can be improved through advanced techniques such as feature engineering, tuning, and ensemble methods.